Communications and Outreach Manager at SOSSEC. I'd like to welcome everyone to our joint DCO SOSSEC Cyber Talk. Today's Cyber Talk is with LogZilla and Axellio. Their event is the intersection, their event topic is the intersection of advanced technologies for real-time countermeasures. Speed of indexing is the new determinant of success. We're happy you all could join us. Your speakers today, your speaker from LogZilla is Mr. Clayton Dukes, CEO and CTO, and your speaker from Axellio is Mr. Hollis Beal, Director of Technical Marketing. Before I hand it over to Clayton, I'd like to remind everyone to keep their microphones muted during the presentation. You are welcome to ask questions in the chat, and we will have a Q&A session at the end of the talk. During the Q&A session, if you have any questions, please unmute yourself, announce your name and company, and you can ask your question. So with that, let me hand the mic over to Clayton. Over to you, Clayton.
All right, thanks, Alex. All right, so a little bit about LogZilla before we get started. The company was founded in 2012 with a primary goal of making centralized log management not only affordable through technology and scalability, but making your jobs easier. And this is actually what's made LogZilla so popular in the federal space, given the, the way that troops turn over and having to learn new things and coming in and out of this space on a regular basis. So as we go through this, you're going to find out just how easy LogZilla is compared to some of the other options out there. But today I want to cover the ability to scale, not only scale, but to automate your tasks, make your lives easier, and we'll show an example a little bit later on of threat hunting as well. So the top reported concerns, hopefully everybody agrees with this, and if you don't, please put it in chat. By the way, I'm not a fan of monologues, so I encourage everybody to ask questions as we go through this. On the operations side, everything is real time. Everybody's adding more and more these days, and it's getting very expensive, of course, to do so. So we'll talk about the cost here. As we add more data, I think everybody has been kind of fooled into, the footprint kind of idea where, hey, we'll put in a small installation and then 3 years later it's $10 million. So that's one of the things we help you avoid. The next part of this are those pricing models, right? So they're a bit tricky. And they're all space-based, typically space-based. I wouldn't say all of them, but let's say you start out at 1 terabyte a day, and then when you go to 3 or 5 terabytes, it becomes something that just is not cost-effective at all. This is more traditional operational awareness. Everybody gets alert fatigue, and I'm going to show you in a minute how LogZilla fits into the traditional FCAPS model, fault configuration, accounting, performance, and security, and how you eliminate that alert fatigue or separate silos of information, right? So something bad happens, I get an extra 50 emails from every tool in the process telling me it's broken. And then the ability to expand threat response. So there's obviously a lot of really good tools out there for IDS, IPS, tools like Zeek that are freely available, but it's a little bit cumbersome to go through logs. Incidentally, LogZilla itself, the product, the first incarnation of this was in 2004. It was an open source tool that I wrote called PHP syslog-ng. My goal at that point was to get away from this problem where my guys were having to sit on a console and do grep and tell for in a data center that we were running. And it became a big problem. So my thought was, hey, why don't I put it in a user interface and make their lives a little bit easier, and my life in the process, of course. We'll take a break here to talk with Axellio and specifically Hollis on how we achieve the scale that we're achieving up to 10 terabytes a day. And Axellio is our partner in this to talk about how to do that. And with that, I'll pass the ball over to Hollis. Who has it? Good job.
Thank you very much, Clayton. So I want to take this minute to thank everyone for joining the call today. We really do appreciate you taking the time out of your day to listen to what us talk about the new product, because we are very excited in what we think it can do in the capabilities that it does bring to the market and to your environments. We know that you're all unmuted while we're talking, but please, if you have any questions, go ahead and put them in the chat. We do have people standing by that are monitoring the chat that we can go ahead and try to get those questions answered at the end. Okay, so without further ado. So first, a little bit about Axellio and kind of who we are. So we're coming up on being a 25-year-old company. We've been started in the late 90s building enterprise data storage systems. So at one point, we were bought and spun out by Seagate Technologies, but our engineering skill set is really focused on high-performance data flow with extremely high reliability. Now, a few years ago, we started a research project with Intel around NVMe solid-state storage devices and the applications that could use them. So this has become the basis for the product that you are going to see today. But after selling off the enterprise storage business, we're focused now on the high-performance packet capture and analysis market. Now, we found a great reception to our approach in solutions ranging from cybersecurity to high-volume IoT sensor telemetry data and even high-speed analytics of financial market data feeds. So in addition to the customers you see on this page, we're about to add one of the major U.S. financial exchanges logos to this slide as well. So in this solution, we're performing high-speed trade analytics on something called the Options Price Reporting Authority, or OPRA, data feed. So this data stream comprises real-time price information on exchange-traded securities from 20 different markets covering all equities, indexes, and ETFs with listed options. So we're very excited to hopefully add them within the next, Mark, help me out here, maybe week or two if we're lucky. But today we're really here to talk about how we can make an impact to your cybersecurity operations. Excuse me. So we've all been used to focusing on external threats where you concentrate your efforts on data coming into or out of the organization at centralized points. Things like routers, gateways, firewalls, things like that. Now, historically, we did this because that's where most of the threats were coming from. But today we're seeing double-digit growth in cyber attacks and traffic, and scaling these systems has really become more and more difficult and expensive. But there's an even bigger class of threat out there, and that's really from threats that are internal to your organization. So internal threats have really quickly become the new frontier in cyber operations. Initially, our networks, generate this vast sea of log files and internal communication as just part of what they do on a daily basis. And this can be a tremendously large environment for someone to try to hide in. So from one study we reference, it states that about a third of all threats are coming from within your network, not from the outside. So when we look at systems that we use for external threats to now also handle the internal ones, the problems of scale just get larger. The time it takes to identify threats get longer, and things get a lot more complicated. But Axellio, our goal here is to enable you to capture more data and be able to look at it faster and easier while leveraging your existing monitoring and analysis applications. So this approach lets us find threats faster over a much broader range of data for a fraction of the cost and complexity. So, it's no secret that external traffic is increasing, and the current pandemic has really caused this to grow at a much faster rate than anyone thought. And the challenge that these systems are facing are really from how we've been building them. Typically applications are essentially stovepipes onto dedicated hardware, and each have their own function. So you have dedicated stacks for, say, intrusion detection, security incident and event management, performance monitoring, and for the operators to actually look at the data and take action on it. So on top of this, you have data coming in from lots of different sources like taps and spans and aggregators and packet brokers, oh my. So you end up with this Rube Goldberg-like machine where the process flow, has this challenge of just dealing with the external traffic that you have today. But the new frontier is really in dealing with internal threats. And now, I'm not just talking about people that are maliciously trying to do something, but really about the unwitting users on your network. A recent study that we quote all the time says up to 98% of all malware infections are through email. Now, while this number is just ridiculously large, this is like cartoonishly number huge large, the recent SolarWinds hack has really shown us that supply chain attacks can even have a much further reaching impact than even just this malware coming through users' email. And the internal threat, this is not the same for everyone. Some industries are a lot more prone to these kind of vulnerabilities than others. But you know what, even at the low number of 36 to 34%, I think everyone on this call would agree that these levels really represent a grave concern to us all. And the adversaries, they're really not making this any more easy. They're constantly innovating, they're evolving to make it much harder to find them in the first place. A hacker could be in your system for months without any kind of detection from you, learning about the organization and its processes, and gathering intelligence for future attacks. And one example I like to point out is, even FireEye, they're one of the leading cybersecurity companies in the world, and these guys are the pros. It even took them a few months to find the SolarWinds problem. So this is definitely not something easy to do, but definitely a place where we've got to get better. Now, just monitoring the perimeter or the north-south traffic on the network, that's really not going to be enough to catch the bad actors once they're in. Once there's malicious software in the environment, it can be extremely difficult to detect, as most malware is now self-contained, so it tries to minimize its communication with external command and control servers. So you really have to watch the lateral or east-west traffic movement for when it tries to reach out from that initial compromised system to see what else it can get at. So remember on the last slide when I talked about some of the challenges that this growing volume of data had on the perimeter defense systems? Well, monitoring the internal traffic is going to increase that volume of data by a factor of 4, 5, or even more. So for example, if you're talking about internal systems, let's say we have like a multi-tiered web application that can have, say, a load balancer, multiple front-end web servers, an authentication server, an application server, and even an object or a file storage server. All of these systems are going to be just talking to each other like crazy and generating just an enormous amount of traffic. But even beyond that, if you're using any kind of a microservices architecture or containers, you can have these entire stacks of solutions that are ephemeral. They just spin up and spin down, they change locations, they move around. So it can be tremendously hard to try to track what's going on in your network and figure out what's supposed to be there and what's not supposed to be there. By having to look all this, these problems of space, weight, power, scale, complexity, all of these go up, and usually in an exponential and not linear way when you have to monitor all of this traffic. But ultimately, we really have no choice. I mean, you simply have to monitor the environment at this level to catch and protect from the threats that are out there. And now, while the software components to monitor, analyze, and report have been getting much, much better recently, and you're about to see one of these with LogZilla in the demo in an upcoming slides, it's the underlying architecture of how we're putting these solutions together that has to change to be able to keep up. So when we're talking about changing, we're really thinking about changing the traditional deployment paradigms that we use to get beyond the problems that these traditional solutions have. And to do this, we really focused on 3 key areas. First, we changed how we're collecting and storing the network traffic. So one of the advantages for us is our extensive knowledge really in high-performance storage systems. From that, we've built software that can continuously capture data at up to 100 gigabits per second with no drop packets. Now, with that, we also leverage the newest technology in terms of data capture and acquisition cards so that we can support data rates of 10, 25, 40, 100 gigabits per second, all from the same card. So this makes the system much more flexible and scalable to grow as your needs and your data volumes do. And because we're using high-capacity NVMe storage devices, we can provide up to about 1.3 petabytes of capacity for storing network data. Now, depending on what your capture rate is, I mean, this could represent days, weeks, or even months of capacity, depending on your capture rate and how much data you need to store. But once you have the data, now you need to actually get the analysis applications, or get it to the analysis applications so that it can actually do work on it. And you may not necessarily be talking about a single analysis application. Intrusion detection systems such as Zeek or Suricata or Snort, these all can give you unique insights into the network data stream because they look at different things and operate differently. So to support these operations, we've developed software that can stream the stored packet data to multiple endpoint applications. And we do this adaptively, so we can adjust to the speed that the applications can run at. So by decoupling this idea of the capture process from the distribution functions, we can now fully virtualize these applications. So the end result it gives you the advantages of scale, cost, and flexibility that virtualization can provide to these applications, that typically require dedicated hardware and those, application silo approaches. But ultimately, it's really the human that's the decision maker here, and there's no one right way one way that each other human is going to examine this data, or each different situation is going to demand to examine the data. So the detection systems, these things can throw off alerts, all day long. But if the operator can't easily get at any portion of the data they need to look at, that's going to increase the time it takes to find and respond to the threats on the network. So we've created a process data flow where the operator can extract the raw PCAP data from any time frame just using standard packet filters. So this enables them to respond to incidents that the detection systems flag in much less time. So now that we've gotten beyond the things that have limited the traditional approaches to network security, we can provide a platform that's faster, cheaper, and easier to work with and scales as your needs do. So, in summary, when we talk about the Packet Express platform, we really see it as what we're calling a network visibility hub. So with traditional approaches, each different application is going to require their own hardware. Usually it's an appliance-based approach. You have to design these applications to handle the peak workloads they're going to encounter. And the real challenge here is that you're really overbuying on hardware, you're overbuying on software licenses just because you've got to handle, that one peak that happens at maybe noon or 1 o'clock when everybody comes back from lunch, but the rest of the time the system's doing maybe 30% of what that is. But the problem is you have to design it for peak, because if you don't, it's going to start spilling packets all over the floor. So this makes these solutions, this drastically can increase the cost and complexity of these solutions. And if you ever really have to get access to the raw packet data, that kind of function is usually not part of the regular workflow of these detection systems. So that's going to require some sort of separate procedure to actually extract the raw data to give your analysts access to what was actually going on in the network, because it may not be something that the IDS flags as a threat. It may be something the IDS flags as something interesting. And you have to be able to, at any point in any of the timelines, be able to go in and just look at anything. So to really go after these kinds of problems and solve these different things, there are several points that we look at where we focus on with the Packet Express platform. So we say this provides a solution that goes well beyond the traditional hub, the appliance model, into what we call a network visibility hub. We capture the data once, then distribute it to applications at rates that are dependent on how fast these applications can actually accept the data. So this allows for you to size these applications and VMs for the average values and not just the peak capture rates. So that can dramatically reduce the amount of hardware and software licenses that you're going to require. And finally, we're going to give you access to any of the packets from any time frame with any filter you want. So this makes the operator much more productive, so they can respond to threats much more quickly. And it's a lot more simple to manage. So currently, the Army Cyber Defense Operations uses our solution as a central part of the Garrison Defensive Cyber Operations Platform. It's called the Axellio Packet Capture Node. It's basically the military version of the Packet Express system. Now, there were a couple of goals that we had with this project, and we really wanted to focus on 4 major areas. Now, the idea is that we wanted to collect data to maximize the visibility into the various physical and virtual infrastructure environments. But at the same time, we had to reduce the number of collection points. So the number of taps and spans and all these other places where we had to connect, we had to make this a lot more simple. So one of the ways we're doing that is we're supporting Gigamon tap aggregators, NetScout packet brokers, and even span ports at speeds ranging from, we have some systems with multiple 10 gig connections, all the way up to systems with 100 gigabit connections in them. And because all of it's based on the same hardware and software design, really it gives you a continuity across all of these different environments that all of it's managed the same. So the next thing we focused on was capturing, storing, and forwarding the data to really make the solution more reliable so that we can capture, again, at any speed for any length of time with a minimal footprint, which has a direct relation to space, weight, and power. So in the solution you're seeing here, one of the advantages that we have by being able to fully virtualize these, some of these intrusion detection systems is we're able to now run, in this case, Zeek inside of a VM. So we have enough horsepower on the nodes inside of the APCM that we are actually processing 2/3 of the network data on the host itself. And now for the other node, we're leveraging the virtual compute environment for what we call off-host processing. So anything extra we needed beyond what we could do internal to our box, we can now just start sending virtual machines outside of it. So this lets you scale in ways that you could never scale before with traditional approaches. We wanted to simplify the analysis of the data for the operators by reducing the amount of tools they have to work with to more easily give them actionable information. Everybody can get overloaded with alerts. You can get overloaded with tools. There can just be too much stuff to work with. We're trying to simplify that down into a handful of applications that we can make much more valuable by giving them unprecedented access to the data and giving it to them in a time frame they've never been able to access before. We're talking on the measure of seconds and not minutes or half hours. And finally, one of our goals was to help the organization evolve from operating in a reactive mode to more of a proactive and even eventually a predictive tempo. So it's about educating the people that are using the system, and it's also about us doing research to figure out new designs and new ways to process data and coming up with easier and faster ways that we can make our customers more productive. So in doing this, we really designed the solution to be placed remotely at various military bases and facilities to really give them visibility into all these different threats I've been talking about today from all different kinds of environments. And whether you're talking about, say, a small base over in the Asia Pacific region, all the way up to one of the, massive, joint bases here in the U.S. So to date, we've deployed these locations or these systems to 15 locations around the world, and hopefully we have many more to come. So with that, I'm going to turn this back over to Clayton, and we're going to talk about a little bit more about LogZilla and jump into the demo.
Let's get going. Here's the fun part, guys. As Hollis mentioned, a couple of things. First of all, Hollis, the Rube Goldberg comment made me chuckle. Thank you for that. But it's really true. And we've been playing the Rube Goldberg game for 30 years in trying to manage all the data that's coming in. And it's funny how people talk about every presentation you guys attend, you probably hear data is increasing, and you've heard it for 15 years. It's not only true, but it's never going to stop. It's just going to keep coming in. And until we figure out how to get a handle on the amount of data, the biggest problem here is that you can't manage what you can't see. Let's take the SolarWinds issue. Part of that problem was Windows generates a lot of logs, and I mean a lot if you've ever looked at the data coming out of there. And so a lot of organizations weren't actually logging the data. So the escalation that happened wasn't getting captured or displayed anywhere or alerted or any of that. So, shame on whoever for letting the hack happen, but shame on whoever for not actually watching for it either. So we're going to talk about how speed of indexing is really the determinant of success, right? You can't manage what you can't see, but you can't build an infrastructure to do 100 gigs per second and expect to do it on, anything less than, 200, 300 servers involved. One of the key things for LogZilla is the ability to ingest quickly. Secondly, to enrich that data, and then third, to orchestrate. On the ingest side, a single server for LogZilla can do up to 10 terabytes a day. Realistically, possibly even more. I like to keep it realistic, but we've had it in the lab at 36 terabytes a day. So that goes down to the amount of complexity in deploying solutions like this and the cost of doing so, right? You go from spending millions to I don't know, a couple $100,000 on hardware maybe, but whatever the case is, it's a huge savings. The next part of this is getting you as the operator away from the humdrum day-to-day things like searching and logs and awk and grep and all the fun things us nerds like to do. Instead, why don't we tie it in with multiple sources of information so that you know everything about that affected entity when the event comes in. It's just added to the event in key value pairs. As an example, maybe like a Windows event, they all have an event ID attached to them. So why not take that, put a link to the event ID description and more information on it, such as what the event actually means, instead of your guys just sitting there looking at event IDs all day. And then finally, as operators, we know how to fix 90% of the things that come in, be it on NetOps side, SecOps side, or whatever. At Tier 3, we've seen this problem before. We probably have a script that fixes it, but it has to come to us, and then it's a manual process. And when humans get involved, it raises the mean time to restore drastically. So instead, we give you a way in LogZilla to just kick that off based on a real-time trigger and go and check everything that you would do. So check check the firewall or check this database or do that thing. I can give you a specific use case that is, I think somebody on the call might be familiar with. We were in there just kind of visiting and saw one of the laptops in the battalion was going out. I think it was a couple hundred times a minute looking up a porn URL. Well, of course, we know not any of the troops were doing that, but it ended up being malware. But it took about, once they saw the event, it took 15 or 20 minutes to track them down. They had to go to Meraki, find out where that MAC address was located, and then find out which user it was assigned to. And so I said, hey, why don't we show you how to just do this in real time? That same event comes out. We go out to Meraki and look up all this information for you. And a second later, that information is not only right in front of you, but your internal communications, which I can't remember what it was. It was a Slack-like product. You could just notify that user, hey, shut off your laptop. And it was his personal laptop. So that's a pretty good example for that. All of this goes down to saving time and being a lot more proactive in your response to how to handle the deluge of data that's coming in, right? So we'll go through a few use cases. I think there's 4. These are customers currently, but this would be the why of why they did this. So the first one was investigation enrichment. They needed full audit logging. And of course, when you say full audit logging, now you know there's a lot of logs, right? And the cost and the simplicity were the biggest things for them, but the speed of being able to see immediately what's going on. In this scenario, they had installed LogZilla and within seconds saw a distributed denial of service attack coming in through their main firewall, Palo Alto firewall. And the second one, it's Fortune 500 financial. They're using Splunk primarily. They're going to put LogZilla in front of it. They're already starting to. And I'll talk a little bit here in a little bit about this deduplication algorithm that's automatically part of the product. In any network or IT ops, you always have duplicate events when it comes to logging. It's just the nature of the way it was designed. And so these companies that are using other products are having to pay for when software is charging you based on the amount of data stored. So they're looking to solve or save, I think it's close to $2 million a year but not actually lose any of the fidelity or information. In fact, their Splunk side's gaining information because of the event enrichment that's going through it. Other thing to note is that ours is running on a VM. They have close to 100 systems on the Splunk side for it doing its job. And the other key thing here, and the thing that really got them going on this, was there was a planned upgrade on the network. It was a bug that just started flooding all receivers, that downstream log receivers. And LogZilla was actually the only one that caught the data storm. Everything else had just either dropped it or lost it on the wire or whatever the case was. Next one is self-healing networks. So this goes to the orchestration piece, where they had approached us, and their engineers, they have labs that run 24/7. So they call them labs, but because of the company, their developers are constantly bringing up switches and testing, and so it's really considered production. One of the issues they had is they'd bring up a virtual switch, or somebody would, and it'd create a duplicate MAC address and cause problems, and then they'd have to go hunt it down through, down the fabric path, down the spine, and all that stuff. And it took a long time to, first of all, to even know about it. Secondly, to fix it. And so we showed them in a pretty simple way how to do it in just a couple of seconds. I am not watching chat, so if anybody has any questions, please feel free, and one of the other guys will let me know. All right, so the next one was actually a fun one for me, because we ended up turning this into a webinar. It is on our website. I think it's called To Catch a Thief. But it was a university that would have laptops go missing, and whoever stole it would wipe it, come back onto the network, sit down in their class, and as soon as they log in, we've got their username, but we also had the MAC address from the stolen laptop. And we took that MAC, went over to Cisco ICE Identity Services Engine, tied that to the username, then go to the wireless LAN controller, map the AP tunnel name to the access point's full name, which then went to their inventory database, got the building, the room, and the hallway and the room that the APs are deployed to, and then went to another system for their security and got the detective's phone number and case ID and sent that to the detective. The entire process took 5 seconds to do. And so the problem they had before is they knew the laptop would show up, but they couldn't get to it in time. That person that took it was in another class by then, or at a different location. The URL's here, and I think we're going to hand out the slides afterwards, so you'll see the URL here for the webinar. All right, so hopefully everybody's familiar with this, especially in military. The OODA loop is quite common. This is one of my favorite quotes: decisions without actions are pointless, and actions without decisions are reckless, right? So I always like to say you can't manage what you can't see. So if you're not looking at it, you're just waiting to get in trouble. And so the way that LogZilla fits into the OODA loop is, you'll see on the left side just different types of data coming in. In today's example, we'll use Zeek IDS for that. And you can see the big giant arrow here on the left. That's all the data coming in. We pass it through the loop, deduplicate it. Everything in LogZilla is real time. So this is another key thing, right? If you're getting a data storm or an attack, and all of a sudden the tool you're using takes 15 minutes to search for results, then you're kind of dead in the water, right? Next, make an informed, intelligent decision, because the system's already gone out and gathered all the information from that, right? Where is it in our network? How important is it? What's the inventory? Who owns it? All of those things can be put in there in real time. And then automatic repair, if that's an option, right? And even in cases where maybe you have tight change control policies, then fine, open a change control ticket automatically and put the commands in that are needed to fix the problem until somebody can get to it. at the end of the day, on the right side, it's about paring things down to actionable data. Don't show me the same billion things every day that I don't care about. Show me the 20 that we need to take action on, and take action on them if you can. All right, so architecturally, the way this fits together, anybody who's technical or has run NetOps or SecOps are familiar with the FCAPS model. This is just simply, for those that don't know, it's fault configuration, accounting, performance, and security. And it's an ITU model. It's been around forever. It's basically saying if you're going to design a operations center that manages your stuff, you should at the very least cover these areas. The key thing here is that all of those work across the network management platform. But what we did with LogZilla was put it up onto the service management layer to be able to coordinate everything, but at the same time promote the other tools up to that area to eliminate the separate silos of information. And Hollis mentioned silos when he was talking, right? It's the Rube Goldberg and the alert fatigue, and we have 20 or 30 tools that send us emails all day. Quick side note, I'm not a fan of email. As an engineer, when I was an engineer for a very long time, you get 300 emails a day, and we just filter them into a folder that we don't look at because who has time for that? So, in the traditional sense, monitoring tools don't actually fix problems. They just point them out, but that has never really helped any of the engineers in the process. So if we break that stack down, you'll see your common network layer and then the elements that communicate up from there. On the network management layer, this is where all the tools fall. Some tools will fall in multiple areas, right? So something like Splunk has fault management, performance, and security. But none of them really communicate with each other. This is where I'm talking about, it's just going, hey, something's broken, go fix it. And so are the other tools that are in place. Or you have some poor guy at a console looking for bad things all day. That's not fun either. So with LogZilla, if we move that up to the service management layer, you're able to have visibility into known error database and inventory and documentation and incident management and problem management and all of those. And you're tying everything together so that these systems are able to forward all of their events up to LogZilla to do the enrichment and correlation and orchestration. At the end of the day, now you have all the feeds from the left, you're coordinating multiple inputs and outputs and getting into in-service assurance, and then able to route it downstream to other receivers that need it. Key here is they're not getting, let's say, 100,000 of the same thing in the last minute. They can get one that says it happened 100,000 times, and by the way, here's everything you could possibly know about it. So at the end of the day, those tools are getting a lot smarter because of it, right? What about ease of use? What about, should I have to hire professional services to build my tool for the next year, or should I just be able to install it and get to using it? This is one of my other big peeves. I was at Cisco for 9 years, and they're notorious for their 400-page install guides. But it's not just Cisco; it's pretty much everything out there. Personally, it just seems to me like companies make things overly complex to make you go to training. I don't know. So real focus for us was to make it easy to install. It's a single command, no questions asked, fully operational. You'll get some sample dashboards with it, and there's plenty other available for other vendor types as well. The ability to remove that complexity. So in my day-to-day job, I know SQL really well. I certainly wouldn't want to do it every day when my job was supposed to be a security analyst. So why would I have that in a UI? Imagine if you had to go to Google and type SQL commands, right? We'd still be using Alta Vista or whatever it was, Prodigy. Manimal. Okay, so the next part of that is eliminating those data storms. You can see on this little screenshot here, typically out of the box, we'll see between 40 and 60%. There's a ton of normalization you can do as well. On the security side, it tends to range between 20 and 40% out of the box. But again, plenty of stuff you can easily do within a matter of minutes to normalize. And then the final piece of this is to do it in real time with millisecond accuracy. You can see that screenshot there. 250,000 events per second is 11 terabytes a day, and we're doing that on a single server. That screenshot, by the way, is from Cisco Live. So we actually did that all week long at Cisco Live. All right. You guys are making me do a monologue, but yeah, somebody said, can we ask questions here? Yes, whoever asked that, please do. I like the interaction. I miss everybody. Okay, so this is a screenshot from a pre-sales customer. Everything's been anonymized, but I keyed in on something. When we were talking to them, they said, well, we already have it installed. I said, great, let's use your data. So I took a look at it, and the first thing I noticed is the amount of duplicates. Remember, I said out of the box 40 to 60%. So 97% is extremely high, and you can see right away that they're getting some type of data storm. But if we look at, this was their Palo Alto dashboard, we see a bunch of random users going to a bunch of random places. Naturally, my first question is, do you have locations in China and Russia? Knowing the answer was no. But when you drill down into this, you can see there was malware on the network with call homes going out, and you could see the traffic, and you can see that just one of the random users was calling home 200 times per minute. So that's what was causing that data storm. Now, how do we normally handle this, right? So if I build out an infrastructure to handle log data at 2 terabytes a day, but all of a sudden it spikes to 10, what's going to happen with that, right? They're either going to get dropped somewhere, maybe servers aren't, I deploy 20 servers to do this and not 200, but who's going to do 200 just in case? Or 99% of the time, they just slow to a crawl. And this is the biggest problem that we see. When bad things happen, we can't actually get to the product we purchased to determine what bad thing that is. And of course, that's when we need that information the most. So along those lines, as I mentioned, we do automatically deduplicate. One of the other things we realized several years ago was we have this amazingly fast engine. We have this ability to do the deduplication enrichment. Why don't we make it available for other things? And that's kind of, probably 5 years ago, that's when we started to move up that stack, that ITU stack, to the service management layer, was being able to route, do message routing between everything and enriching and all of that. So now we can sit in front of everything and kind of be that train coordinator, that we take all of the data in, we do the deduplication, we do the enrichment, and then we can pass those downstream to any other tools so that your cost goes down on those tools. So even if you have another log analytics tool, or of course any SIM tools, or a messaging platform, or whatever you want that receives either logs or traps or files or webhooks. It's just only traps and logs mentioned here, but we can bring it in any way and send it out in any way. I do see a chat here. Can you touch on some of the analytics used to find command and control? Yes, we're going to. Thank you for that question. In fact, we're going to do that right now. So at the end of the day, it's reducing those license costs, but making things easier for the operators, right? The people that buy it, they care. Obviously, federal cares a lot about how much it costs. But the people that use it have to do this day to day, and it just gets exhausting because you keep doing the same things over and over again. And why don't we just free your life up to do something a lot easier? And let's talk about how easy it is now. What we did with Axellio, we set up everything on their systems, and they are generating quite a few events from their Zeek IDS. So today we're going to take this walkthrough to learn how to do a few of the things. So quite simply, what we did was went out and looked at what people do normally for threat hunting, and then made a comparison of what you would do in Zeek versus how it would work in LogZilla. You're losing nothing. You're gaining a lot more visibility and a lot more ease of use here in this process. Do you have custom network analytics to detect bad is another question. Bad. Let me get through this and then ask that question, please. I like that. Thank you. Hey, whoever's setting me up for this, thank you very much. Appreciate it. So rather than hunting, why don't we just give you a real-time way to look at it? And even if there's something that's not already on the dashboard, why don't we give you a way to easily get what you want? I'll show you a couple of examples here of that when we look at it, the actual product. And that was kind of the main goal here, is get you guys away from command line, Zeek cut, awk, said, all of that stuff into, hey, it's already here, let me just take a look. And then, of course, find a much faster way to get what you're looking for, right? So let's look at some of the activities we would normally do on a day-to-day basis with Zeek. We want to find connections that originate from some IP address. Here's what you would do on the command line. This would put it out to a text file that you would then look through the text file to see what's interesting, right? We still haven't solved a problem, we just made it viewable at this point. Next thing would be track source to destination pairs. This user went to that place. This user's going to that place 100,000 times more than any other user in the organization. Okay, that's a problem. Now let's discover services used in the network. Easy enough to do, but here's the thing in Zeek, this is, it's not this one. I'll show you another one here in a minute, but a lot of the ports come in as port numbers. So what you can do in LogZilla, as it comes in real time, is transform that into human-friendly things. So instead of a pie chart with a bunch of port numbers on it, why don't you get a pie chart with, 22, which is SSH and FTP and HTTP and all of that. It's just a lot easier to look at, right? The other thing was just common top ends, which absolutely extremely important. That's usually when I was doing this kind of stuff, that's the first thing I would look at. It's the Pareto rule. If you take care of the top 20% of the noisy things, usually 80% of the problems go away. So top ends are extremely important to look at. And then finally, identifying C2 communication beacons, malicious DNS, things like that. But you want to filter out the normal stuff, right? Microsoft, Google, things that people are always going to. Otherwise, your pie chart's just going to be 99% those and 1% of the other things. And of course, again, now it goes out to a text file that you have to review. And so good luck spending the next hour looking at those. Okay, so here's a sample log entry from the con log from Zeek. These are, you can do them in JSON or TSV, but these are TSV. And you can see the fields that come in, they're named, UID, originating host, originating port, all of that. And it's kind of, yeah, this is the resulting text file. You'd get this line at the bottom of things that you'll have to look at when you do the command line awk and set and all that kind of stuff. So still not very fun. Now, here's the same log in LogZilla. The entries are converted into key value pairs, much easier to read. I know the source ID, port, destination port, all the services, everything. I can read this a heck of a lot easier than I can read this, right? Hopefully everybody agrees with that. That's the same log entry, by the way. You can see the responding IP here matches the responding IP here, right? So there is a wealth of knowledge that comes from Zeek, not just Zeek, but Suricata, all of those. They have a ton of information, but along with that ton of information means a ton of hard work for people, right? They're doing their job, they're doing it really well, but you've really got to have something on the other side of it to get a handle on all of these things. So instead of all the command line stuff, why don't we just end up with this, again, real time coming in as it happens versus, hey, let me go search once a day and find out the bad things that are happening, right? So for the guy that asked, John, about detecting bad, here's bad. Let's get away from, I know that the word detect is kind of works on both sides, but it's get away from the hunting part of threat hunting and get more towards threat viewing, if you will. Here are the threats, right? One of the things I won't cover here, but LogZilla has a lot more power into, and I mentioned this previously, taking action on that, right? If I see a high number of connections coming in, what do I as a person do with it? Well, I'm going to do some investigation. Instead of me doing that and taking the hours to do it, why don't we just do a real-time trigger that goes out and does it for us? That makes things a lot easier. And of course, there's a lot more dashboards. You'll see in this demo for the technical people, it's well documented. We put it out on GitHub. All of the dashboards and everything, rules and everything are included. If you actually want to do them based on your own deployment, we even included a script that will automatically build all the rules and dashboards for you. So for those guys that are stuck building dashboards for weeks in something like, I don't know, Elastic, you don't do that. It's done in a second here. Somebody asked about SOAR functionality. So yes, the answer is yes. And those are the things I alluded to earlier. We're just, when you talk about event enrichment and event orchestration, that really is SOAR. Incidentally, one of my friends, Anton Shuvikin, I think, is the one that coined that term when he was at Gartner. He's also a reviewer on one of the papers that I authored while I was at Cisco. So he was really good at giving cool names to things, and SOAR has just soared, but it's been called other things over the years. Sort of like big data has been around forever. Somebody named it big data, and then it got really cool, right? All right, so let's take a look. I'll pause, or really I'm going to pause for a second and share it anyway. So if anybody has questions, please ask. All right, for the fellows that can talk, can you see the browser? Or just put it in chat? Yes. Okay, thank you. All right, so here's that, some of the screenshots you saw with the threat hunting. Currently, there's about 20-ish thousand events per second coming in to the system. That's from the Axellio stuff that are replaying all the PCAPS, right? And you can see in the dashboard some of the things that we went through, long duration connections, post non-centered ports. One of my favorite actually was top 15 connections to destination ports above 1024. And you can see right here, here's one guy, one thing. I don't even know if it's a guy at this point, but one thing going to 5440. What's 5440? Well, I don't know. It's not a well-known port. You can see the other things here I mentioned. Remember, I said map the well-known ones to names so that I don't have to guess what port they are. So I immediately know this is not a common thing. Let's click and find out and see what this person or this thing or this system is doing. There are currently 6.2 billion events in here. And you can see that the search results come up in somewhere usually between 1 and 3 seconds. You'll also see a lot of helpful stuff in here for doing the analysis to take it further. So I have a destination IP, everything's context sensitive. If I click on that, I can do common things, DNS query, ping, trace route, whatever. If it's an external IP, it'll give you a geo IP lookup. I can go, hey, look, something's coming or going out to China. Huh, that's curious. Well, why don't I as a person now go investigate all that and do it manually? I'm going to log into this, check that. Check our database, see if it's an authorized IP, find out it's not, go to the firewall, block them, open a ticket, do whatever. Instead, why don't I right click, execute a script that goes out and does that for me. Bada bing, bada bang, you're done. That was hard. At the same time as these ad hoc scripts, you can actually go and do a real-time trigger that does the same thing, but matches on future events coming in. So if I wanted to create that, put some filters in it. One other important filter here for everybody is the ability in the system to mark events as actionable or non-actionable. Just like I can create a trigger to mark something as actionable here, I could also create one that's non. And I mentioned this briefly earlier. It's simply get me out of looking at a billion things a day and put me into the 20 that I should be looking at. So everywhere in the system, no matter if it's in the query bar or in the widgets themselves, you can actually filter based on those types. Conversely, I would have a widget here that says, only show me unknown events. And the day that that starts filling up, guess what you got, all right? Pretty easy way to see that something bad is happening. So back to the triggers, if I go here, I can match on that event thing. I don't know, this IP range does this, that, or the other, or looks this way or that way. I can filter based on the common log type fields. I can also base it on user tags. In LogZilla, user tags are extractions of message components. So if I look at a message coming in from Zeek, then I can say track everything that has a source and destination pair, and then I can create a tag of it that has source to destination or source to destination port, right? So I'll mark that as actionable. I can send an email that nobody's going to read. I can send a webhook, which is handy to ticketing or messaging platforms. Adding a note would be the ability to do things like internal tribal knowledge. We know what this event means. Here's a breakdown of it. Here's what we normally do with it. Or something like, we know about this problem. Here's ticket number, whatever, whatever. It just gives you an easy way to attach notes to future events. Issue notification would simply put it up here in a badge with the message itself. And then finally, the ability to execute a script. This is actually my favorite part because you can put whatever kind of script here, assuming you have access, but you know, Perl, Python, Shell, whatever. And us guys that do this day to day, there's a spoiler alert. Every network on the planet runs on scripts. When something breaks, we just kick off a script because we fixed it 80 times already. And so the nice thing here is this gives you the ability in a more open way. It's not, hey, let's design some new language that you have to learn. Rather, it's, hey, you can write a shell script in 5 minutes that will go and check this thing and look that up and verify that other thing. On the network side, let's say an interface goes down. Well, was it an authorized change? Was it in compliance? Maybe the wrong interface was shut down. Why don't I put it back into compliance? But I need to check change control first. And so all of that's done quite simply in a script. There's actually examples on our GitHub for doing it. None of it is extremely hard. Clarification from Mark.
Yeah, Clay, this is Hollis. I
Mark?
would actually add here that extraction process that we talk about, where the user is actually able to go and do an on-demand extraction, give it a time frame, give it some Berkeley packet filter information. You know, those scripts could be executed from this script path right here. So you can even have a pre-done script where if you do see an IP address or you do identify something that like you want to put a trigger on, we could actually create a trigger that would automatically do an extraction of the data. At that time frame, we could even specify, you know, give me 3 seconds before and 3 seconds after, and it would extract from the actual raw PCAP file that you have stored on disk with us. It would extract that data and save it as a PCAP to your local device for analysis in whatever package you're going to use.
Good point. And even take it a step further, you can loop events back into LogZilla. So do the extraction, make an analysis, generate a new log that comes into LogZilla that even kicks off another trigger that does other things. We have customers doing that with, one in particular that comes into mind was with BGP VPN tunnels. They're doing the analysis on it, but they don't want action taken until it meets specific conditions. Good. Thank you for that. Appreciate it. So real quick, I'll talk about ease of use. By the way, I didn't tell you at the beginning, but I am not a fan of 2-hour webinars. I would fall asleep if I was you guys. So I'm going to do you a favor and not make this 2 hours. And I guess, you know, for products, it probably does take 2 hours for some of them, but it won't take that for ours. So we're going to create a new dashboard. And this is done for users, right? I firmly believe that the term UI is user interface. It's not admin interface. If it was, it'd be called AI, and maybe that'd be really confusing for people. So as a user, I'm going to go in here and do some whatevers. You can see the top end types. Maybe I want to see events per second, or I'll do another top host here. So top end just means top something. It defaults to top host. But if I want to see top Cisco events or whatever, top source to destination pairs, then I can go here. I can also further filter that, as I mentioned. Maybe I only want source to destination pairs that exclude a specific IP range, right? I could even put EST IP equals, and then maybe not source IP equals something else, right? So we can really further filter that down super easy. Maybe I'll put this in a grid view type, and now we have our source to to destination pairs visible right there. So let's see here. I want all the top hosts with the word failed in them, but not the word error, and off I go. I didn't have to do any SQL commands because those are always very fun, right? So from here, you just drill down, get the data you're looking for, and take action on it. Or my preference is actually create a trigger that takes action on it, right? As we know our infrastructure, we learn as we go along, we do our daily stuff, we turn that into things that don't bore me for an hour and a half every day because I keep having to do it, right? So all of that's right here in front of you, quite easy to see. And then you have your dashboard, right? So in terms of security, everything is role-based access control. Specific people can get access to specific things in LogZilla, be it a dashboard, be it a host. You can group, put devices themselves into groups so that only this group can search events from that data and so on and so forth. So completely separated in it. You'll notice also, if you haven't already, the search bar is everywhere. It's more or less just kind of natural language, Boolean, with some exceptions like the ability to do wildcards and things like that. This was mainly on the network side for things like interfaces. You wouldn't know the interface name, like gigabit Ethernet 01 versus 02. So you could just put gigabit star or whatever that you were looking for. And that'll come in. And of course, those same filters apply here. Everything would be coming in. If there were Cisco events, all the Cisco mnemonics are automatically tracked. There's over 1,000 triggers for what Cisco considers their most actionable events. And then, of course, if you look on our GitHub, there's a ton of rules already included. Now, I'll kind of mention this only briefly, because in the next two versions from the current one, all of this is turning into an app store. So in LogZilla, you would just go into settings, and somewhere in here it would say, I have Palo Alto devices, and it puts everything in there for you. So it makes it even easier. All right, what else can I play with? Actually, for smaller teams, which I know you guys do have a few of, tasks are not meant to be a ticketing system, but a quick and easy way for you to track things happening or things that need to be investigated, right? So if we take an event and we say, I want to create, you could create individual notes here, mark them as actionable, non-actionable, things like that. So instead, let's assign a task for somebody to investigate and put whatever we want here. The nice thing about this is I can set the criteria for them and they get the event in context. So instead of you opening a ticket somewhere and having to copy paste the event or do this, do that, I can go in here in the morning and see, hey, my boss asked me to check this out, and here's the event as it happened into the system, right? Very easy to do. Not a highly complex thing. We do really focus hardcore on keeping things dead simple for people to do. For those that want to play in the area of I want to make magical things happen and I like nerdy drilling in, that's absolutely fine. It's here. It just doesn't need to be in a user's face at all times. So there is an easily accessible API on the system. In fact, the UI itself is an independent operator. You don't even need the UI to operate the product. Everything can be done through the API. Next thing is, I was thinking of something, then forgot. Okay. Oh, the other thing was event correlation. So triggers are do this thing right now as it happens, match on a thing and do it. Event correlation is going to be more time-based or pair-based. If I see this and then 3 seconds later I see that, then I'm going to do something with it. So we give you the flexibility to do the most advanced things that you would normally do as your job, only the ability to automate it and do it in a second versus however long it would normally take you to do. one probably final thing I do want to note. I mentioned installing was easy. If you install it, play with it. There's a VM you can download. It's you can paste a command. Let me actually just show you where that is. If you go here to download, this is our 400-page install guide. That's a joke. Just paste that into any system that has Docker running, and it'll be up and running in a few seconds. Or again, you can download the VM from here, which is just an empty operating system that runs this command for you. So your choice. I wanted to mention that help is actually helpful. I know you're probably not used to that, but in help I can search. You know, how do I? Let's see, search. How do I do searches? So here's my search syntax, and you'll find that most of the help pages are only 1 or 2 pages long because we want you to get to the meat of what you were actually looking for, and not a long diatribe of why search was invented and the different types of search, and that's not what I was looking for. So hopefully that helps. If any of you do want to install and tinker with it, it's 7-day free license, and then if you need it extended, it's fine. Just contact anybody that you'll probably get contacted first, but just contact them back and ask for an extension. All of it's pretty simple to do. For the Zeek stuff, if you want to implement this on your side, I mentioned earlier it was documented. We'll give you this link at the end of the thing, but we put that under packages. The only difference between rules and packages are the packages come with extra things like, in the Zeek case, I made a script that would just build everything for you. There are 2 ways to implement this. One would be the easy button, which is down to the bottom because the rest of it's just introduction. So you can use the rules that were already built for you and the dashboards. It'll create all those, I think it's 22 dashboards here for all the Zeek event types. Or if you have a custom setup and you only have specific fields or whatever from your environment, then you can just run this make rules or make rules -d, and it'll include the dashboards, and off you go. Still easy, just not as easy as the easy button. All right, let's see. I don't think I can waste any more of your time because it's just too easy to use. So, yeah.
Clay, can we get you to show the architecture slide for the demo?
You know what? I mentioned that, or I noticed you didn't have that, and I thought you had it, but I don't have it. Can you share it?
Oh, okay. Yep, I can absolutely show it.
Yeah. When you got to the end, I thought, oh, maybe it's in mine, but I didn't even see it. Let me pass the ball back to you. All this. Yeah, of course I don't see you in here. Oh, there it is.
Yep. So what you're seeing now is the architecture of the system of how we have the demo running. So right now we have, LogZilla and Zeek all running inside of this is one of our 3U chassis format boxes. We also have boxes that do 2U. Each one of our boxes has 2 server nodes in it. This is how we're getting up to about 1.3 petabytes of capacity. We can host up to 112 physical cores or up to even 3 terabytes of RAM with supporting capture bandwidths of up to 10 gig, 25, 40, or even 100 gigabits per second. So what you're seeing here is basically we have on one of the server nodes, we call the capture node, we have our capture card, which is a Field-Programmable Gate Array or FPGA-based capture card. It does time stamping, filtering, slicing, can do basic packet deduplication. That goes through our capture software, and that data is stored onto what we call a circular buffer. So essentially, we take all of this capacity and turn it into something where you can just keep writing data into it. And at the point where it gets filled, we'll just start archiving data out of it on a first in, first out basis. Now, while this is going on, we also have our extract functions that in real time, as the data is coming in and being saved to this large circular buffer, we can extract the data and then send it to the analysis applications. So in this instance, we're running 3 instances of Zeek on the second node inside of this chassis. We think we could probably get a 4th instance in there, but we just did 3 instances now because we just wanted to play a little safe for the demo. So again, we're just extending that raw PCAP data up to Zeek through a PF ring interface. Zeek does all of its processing and then sends its logs back over to LogZilla, which is sitting back over on the capture node. So again, this is everything inside of a 3U chassis, which would have normally taken, maybe half a rack to even a full rack of gear with all the different servers you'd need for, each Zeek having its own capture process. You have another server with a couple of shelves of hard drive for the PCAP capture, and then you'd have even more servers for the database that sits in front of it. So with a combination of the Axellio hardware architecture as a platform to be able to load these analysis applications and being able to load the LogZilla software, combine that with the ease of use and the intelligence of the LogZilla software, we can give you a really robust solution that can give you really deep insight into a lot of your different networking needs for a size and really a package that's a format that's really unmatched in the industry today.